created this company nearly 9 years ago.
Oh, wow.
So we are based, as I said, near Paris. So I'm the CEO of the company. We have a small team based here in Paris with 4 engineers. We will have to recruit several people in the next couple of months regarding the fundraising process we had recently successfully. So and we have a supervisory board which is let's say quite powerful regarding the site of the company. So the chairman of the supervisory board is Louis Schweitzer. Louis is a former chairman and CEO of a Renault Group. He's a guy who created the alliance with Nissan a few years ago. And industrial guys. We have Bert Scheckhemper, for example. Bert was a former vice president of Alstom Transport. He's based in Germany. And regarding the fundraising process we just conducted, we also will have people from the investment fund who invested nearly 18 million euros, 1.18. So it's an ongoing process. So here we are. So we have this aspiration device, which is divided in 2 parts. Here you have a small vacuum, which is a small electric brushless motor, plus the rotor, and a filtration device. Here it's divided in 2, the filter itself, plus a kind of cyclone, just like a Dyson vacuum, to increase the life cycle of the filter. And some pipes connected directly with the caliper. Oh, here you have a floating one. So we groove the caliper. We modify existing caliper. Today we are working on conception of new calipers through collaboration we have with caliper manufacturer, just to have new calipers, including the technology. So we groove the caliper to have the airflow passing through and connect it directly with the pad, which is here. So
have you worked directly with like a brake pad supplier to develop the I guess the pad specifically for your system?
Yeah, let me show you another example. So here we have 2 calipers. This one is the one of the Renault Zoe, so it's a small floating caliper. So we modify the caliper by ourselves and ask at the end to the brake manufacturer just to be sure that the modification doesn't, how do you say, fragilize. Is that correct? The caliper. So we have this pipe here, but this one was quite simple. And we did it by ourselves. This one is a Audi RS5 caliper. So it was manufactured by Akebono at the beginning. And we developed a collaboration with a team in Ingolstadt. And the team in Ingolstadt asked us to collaborate directly with Akebono. So we modified the caliper with adding those green pipe and another pipe on the other side. And it was done through calculation with a collaboration with Akebono.
Gotcha. And what about the brake pad itself versus the caliper? Did you have to work with a brake pad supplier?
Yeah, of course. Of course. For this one, for example, which is the RS5, I guess. So as you can see, we groove the pad at the end. The first step for us was to have an idea, a concrete idea, through bench tests we conducted, just to check if we can hear some modification in terms of NVH. So because the answer was no, it was easier to start to collaborate with pad manufacturer. So they conducted all the tests they wanted to conduct in terms of resistance, in terms of NVH, to reach some solution also. But I mean, this is a normal way to do it. And we are doing it step by step, which each brake manufacturer, at the request of the OEM, who have an interest for our technology, which is business as usual.
Sure. Yeah. And I think you mentioned, you may have mentioned it earlier too, but is your system made specifically for the automotive manufacturer to be obviously installed on the new vehicle, or can it also be retrofitted on many different vehicles that are already on the road?
In terms of principle, it could be done for retrofit solution.
Okay.
But as you can imagine, for safety reasons, I'm not sure that it's going to happen one day.
Got it.
If we talk about automotive, for rails, this is totally different, because the maintenance of the train usually is assumed by the operator.
Mm-hmm.
The train are their train. They know their train perfectly well. They do the maintenance. So, I mean, if you want to change the pad, if you want to change the pad holder, and to include the aspiration device, this is something which is normal. So this is something which has been done yet in France. So we are working with a SNCF, which is a French national rail operator. So we are on commercial traffic today. We started nearly 1 year ago. It was 11 months ago. We started in December last year. It's supposed to be conducted for 1 additional year. But I mean, it works quite well. So just to show you, I mean, the size is a little bit different. So for the rail, as you can imagine. So we have this huge box, which is headed to the train. Let me show you. I don't know if you can see the picture here. Here you have a train. This is a French one. This is what we call the RER. This is a train following the river in Paris. So this is a suburban trains with a lot of traffic. So we have the big box in between the two coaches, as you can see. So the box is here. So try to open the door here. So here you have the big box with big filters, which are here. So very easy to change.
Wow.
Big filters, because I mean, as you can imagine, the size of a pad for a train is bigger compared to what you have on the automotive. Here we have the electronic controller to pilot the cycle of aspiration, because it's not just on and off. And here the blowers. So we have some blowers which look like this one, so quite big, because you need a lot of power. And here you have an example of the pad holders and the pads which are modified. So normally pads are grooved. Let me try to find one. The pad for trains normally are grooved this way. So you have that kind of shape.
Yep.
Of course, you multiply by 2. It's always divided by 2 for the trains, because it's easier in terms of maintenance when you want to change the pad. You have that kind of groove because it's interesting in terms of evacuation of water during a rainy period. So we modify. So we have that kind of a shape and network. And by doing this way, you reach 85% in mass in terms of reduction of emission, and 90% in number.
Oh, wow.
So that we capture the biggest particle and also the smallest. And we have more or less the same figure for automotive. 85% in mass in more or less every vehicles. We have some vehicles where we reach 90, 95. The biggest is 97% in terms of reduction, and around 90 in terms of number.
Electric vehicle adoption. You know, on one hand, I'm thinking, obviously with regenerative braking, people are using brakes less often. So is that an issue for your company as far as growing? But then also EVs are heavier. Therefore, I'm assuming that when they do stop or they do brake, they're probably emitting maybe more brake dust than maybe typical cars. So what's your take on that?
Yeah, I mean, our position is following. We consider, I mean, it's going to be more or less the same that what you had with the exhaust. At the beginning, you have a small reduction. 5 years after, bigger reduction, and so on. And the more you decrease the emission, the more the people want to be close to zero. So you're absolutely right. Normally, with electric vehicle and the regen, you decrease the emission, but at the same time, because you had the batteries, which are what we know in terms of mass, you will increase also the emission at the same time.
Yeah.
So it's interesting. When I show you the Renault Zoe, the equivalent in terms of internal combustion engine, which is the Renault Clio, which is the same size, the mass of the Renault Clio is 1.1 ton, and the mass of the Renault Zoe is 1.5. So, I mean, this is evident. I mean, you increase the emission. So, yes, in a way, it can sometimes allow you to decrease the emission, but I mean, this regenerative braking is not a final solution. As long as you will use friction brakes, you will have some emission, and particulate matters release within the air. Mm-hmm. So, especially, I mean, our target was to have the best performances in terms of reduction for urban driving conditions. We do not care what happens today on German high-speed condition. I mean, when you drive at 200 kilometers per hour, I mean, fine. I mean, this is not the topic. The topic is central urban district where you have the higher concentration of population and the higher concentration of particulate matters. Yeah. And unfortunately, because of the traffic, this is a place where you use the most your friction brakes.
Yeah, your stop and go. Yeah, sure. Obviously, I'm assuming there's going to be routine maintenance on the system, like replacing the filter, cleaning the filter. Like, so what's your estimation on how often your system needs to be maintained?
Yeah, we had two topics at the beginning we wanted to solve very rapidly, just to have an idea if this concept was able to have a future or not. The first one was rainy driving conditions. Just because we know that with humidity and water, those particulate matters sometimes glue in between them, and it's very difficult to evacuate after. So, so it was the first point we had to solve. We found the solution. Now we used the car on every driving condition. It works perfectly well, and there is no topic. So, as you said, the huge topic, the huge following topic was the size of the filters. So the first point imposed by OEMs was not to change the maintenance path. So they said to us, that's very simple. We can think about changing the filter every 2 years or 30,000 kilometers.
Oh, okay.
So the challenge for us was to design a filter which retain as much as particulate matters for that period of time. Just to give you a view, this is the size of a filter we used for the Audi RS5.
Okay.
As you can imagine, the Audi RS5, considering the power and the speed and the mass of the vehicle, released a lot. So, I mean, but this is what we used, and with such a box, you can reach without any problem 2 years and 30,000 kilometers of life cycle. I mean, it's impressive. I was impressed. I mean, this is a filter.
Yeah.
Before and after. And just to give you a view, this one, the black one, is after 400 brake actuation on just one single brake.
Oh, wow.
So it means one cab, one day point something of a cab driver for a cab driver in Paris. I mean, of course, I was very impressed, but as you can imagine, it doesn't mean that this is a full one. Okay, so, but we worked very hard with filter manufacturers, focus and specialize on automotive industry to develop the appropriate solution. Because as you can imagine, the appropriate solution didn't exist.
Yeah.
So at the very beginning, we started with cabin air filters, but it was not the appropriate one. So we had to develop something. And today it works quite well. Yeah, we made a choice on day one of the company, which was not to be a manufacturer. So we are engineering company and purely engineering company. So we have 29. We have a portfolio of 29 patents issued in 12 different countries today, and we sell the license of all patents.
Okay.
So today we have signed one first license agreement with one tier one supplier. So we are in the middle, let's say this way, of the industrialization process of the technology. We have a very deep process with an OEM, which will be the early adopter of the technology, and we expect to have the first mass production vehicles just before the Euro 7 regulation, so it means in 2024.
Wow. Okay.
It's a long process.
Yeah, it sounds like it. So is your main is your target customer then like a brake manufacturer per se, like a tier one supplier, or is it the OEM is kind of the customer and then they maybe direct it down to a supplier?
For the very beginning, the only clients we could have is an OEM. As you can imagine, I mean, when you observe innovation within the automotive industry, it's more or less always the same. Normally, you start with premiums, guys, and at the end, you're gonna be everywhere. But I mean, it takes time. So we think that it could be maybe much more rapidly because of the regulation in 2025, 2026. But I mean, yeah, our prime target was to have something with with a premium OEM. So for the automotive customers means OEM. After that, I mean, we can face maybe a situation where a tier one supplier will promote our technology and the development, industrial development they conducted for us to different OEMs. So we can have at the end the tier one suppliers are our clients. But for the very beginning, all clients are and will be OEMs.
Okay.
It's different for the rail. For the rail, we want to work with a final decision maker. And the final decision maker for the automotive for us is the OEM. For the rail, the final decision maker is the rail operator. So this is why we are working with SNCF and not working with Siemens or Alstom or CRC in China.
Got it. What's the out of, I guess, between the automotive side and then the rail segment, which one have you seen seems to have the less obstacle to adoption? Are both pretty challenging, or are you seeing one or the other maybe embracing this easier than the other?
They are both very challenging. for technical or political reasons, which are slightly different for one sector or the other. For the automotive sector, the challenge was really technical challenges in terms of energy consumption, our capability to integrate within the vehicle a new device, which is, as you know, not so easy. To include all the specification in terms of temperature, humidity, and so on, and life cycle globally of the device. It was totally different for the rail. For the rail, it's quite easy. You have a lot of space. You do not care anything about energy consumption. I mean, it's not a topic. The only topic is very simple. Does the political decision maker somewhere in a city or in a country want to tackle this problem or not? Let me take an example. I mean, we had a very interesting meeting recently with a subway operator. 25 minutes, which is when you go at the other side of the planet, something which is not really, you're not really satisfied with it. So, and they said at the end, okay, we wanted to hear about your technology, but I mean, we are satisfied with a particulate matters concentration within our subway. Our question was very simple. What is the level of the PM concentration? We are satisfied. And the day after, we had a meeting with the political decision maker, so the city. And they said, we are not satisfied. And we will oblige the rail operator to develop your solution. Just to give you a view, I mean, we do not have that kind of problem with the automotive industry. It's very simple. You have, is there a regulation or not? I mean, this is as simple as this. We can talk about something which could be an option on certain vehicles, on premium or very, very expensive vehicle, because you want to have clean rims. But I mean, your market will be very small. Mm-hmm. If we want to have access to the mass market, the only topic is regulation. And because we thought that at the beginning that, because a lot of medical and scientific studies had been issued in between 2011, 2012, 2030 about the toxicity of those particulate matters, that something has to appear. And this is why I decided to create a company and to move forward. And this is where we stand today.
Yep. Now, are you marketing your company, your system, your I guess licensing your technology? Are you mainly focused in Europe right now? I mean, have you expanded into other countries, the US or anything like that yet? Or are you still kind of focused in the European market?
And fortunately, we tried in the US, but for different reasons, it was very difficult. Except for California, because of the CARB. For the rest of the country, it was a little bit difficult. And to be honest, because we are a startup with limited resources, we thought that Europe was a huge market for us, and also a part of Asia. We were very proud to be selected by the city of Seoul. A part of my team is today in Korea to conduct the very last test with the city of Seoul and the subway of Seoul. We developed also collaboration in China with CRC, the Chinese OEM, for two cities in China. To be honest, I think we could have several collaboration in China. There is a huge concern in China about air quality and PM pollution. I'm sure you're aware, but I mean, in China, every people usually have information about the level of PM 2.5 on their cell phone every day. So when you go to visit the city of Shanghai or Beijing, and you say, I have a solution to reduce the emission of a certain part of particulate matter, usually the answer is, okay, fine, let's have a seat and let's talk. But I mean, we think that the first market today for us for automotive is Europe. And we know that if Europe adopts soon the Euro 7 regulation, including brake dust emission, with quite important level of reduction, China will be the next market. And then you will have Japan and maybe, we hope, the US, which is going to be the next one. But I mean, as you know, the government in the UK is starting to think about it. We have been interviewed by those guys recently. They said that they wanted to have a law with a regulation of brake dust emission in 2023. We know that the government and some members of parliament in Switzerland are working on the topic. So, I mean, it's growing.
Yeah.
And this is something you will never stop. It's a never-ending story. At the end, the only solution is to reach something which is close to zero.
Mm-hmm. Sure. Yeah. Well, I'll tell you what. So, Christophe, this has been pretty fun. I appreciate you spending some time with me. You know, when I I've kind of read and stayed on top of the company and some of the press releases and the news and some things you guys are doing. So I thought it'd be a great opportunity to kind of learn, talk to you, learn about the company, and kind of see where you guys are going, and of course, maybe kind of help promote the technology and things you guys are doing. So I appreciate you joining me today.